The morning of December 17, 1944 arrived cold and colorless across the Belgian Ardennes, the kind of morning where exhaled breath crystallized instantly and diesel fuel congealed in tank lines like half-frozen blood. German Panther crews sat in their machines, engines idling to prevent complete seizure, confident in a set of assumptions that had been reinforced through 2 years of combat across the steppes of Russia and the hedgerows of France. They believed, with the certainty of men who had seen American Sherman tanks burn like gasoline-soaked rags, that they commanded the most lethal armored vehicles on the battlefield. The Panther represented the apex of German engineering philosophy. 50 tons of sloped armor geometry designed to deflect incoming rounds through pure mathematics. A 75mm KWK-42 gun capable of penetrating 4 inches of armor plate at 1,500 meters. A Maybach HL-230 engine generating 700 horsepower to push all that steel and firepower across any terrain the Wehrmacht chose to contest. The numbers had been drilled into every crew member until they became articles of faith. What those crews did not understand, could not have predicted as they advanced through the snow-heavy forest toward the village of Stoumont, was that the entire framework of their tactical superiority was about to be dismantled by an industrial logic they had catastrophically misjudged. The tactical situation appeared routine by the standards of the Ardennes offensive. 3 Panthers from the 1st SS Panzer Division, moving in textbook wedge formation, had been assigned to clear resistance from a small crossroads village that American forces were reportedly abandoning. Reconnaissance elements had reported sporadic small arms fire, but no indication of armored opposition. Radio intercepts suggested the Americans were in disarray, their command structure fractured by the speed and violence of the German advance. The road ahead looked open. The Meuse River bridges, the ultimate objective of the entire offensive, seemed within reach. Standard operational procedure called for aggressive forward movement, maintaining momentum, exploiting American confusion before they could reorganize. The lead Panther commander, a veteran who had survived Kursk and the nightmare fighting withdrawal through Ukraine, scanned the tree line through his commander's cupola optics and saw nothing that concerned him. The forest was silent. The village appeared empty. Everything matched the intelligence briefing. Then his tank stopped moving, not through any mechanical failure, but because something had just punched through 80 millimeters of sloped frontal armor at an angle that violated every principle of ballistic geometry he had been taught. The penetration occurred at the junction between the glacis plate and the driver's compartment, a location that should have been effectively immune to anything the Americans could field at combat range. The shell that struck there did not ricochet off the sloped surface as German armor doctrine predicted it would. Instead, it penetrated cleanly, generating a cone of molten metal fragments that turned the interior crew compartment into a killing box within microseconds. The ammunition storage detonated half a second later, blowing the turret completely off its race and sending it cartwheeling backward in a shower of burning debris. The 2nd Panther commander, trained to react instantly to contact, traversed his turret toward the suspected firing position while simultaneously ordering his driver to angle the hull for maximum frontal protection. He never completed the maneuver. A second American round struck the narrow gap between his turret ring and hull armor, a target zone perhaps 6 inches wide that required either extraordinary luck or extraordinary skill to hit under combat conditions. The shell penetrated into the fighting compartment and detonated against the breech of the main gun, killing the gunner and loader instantly and setting fire to the ready ammunition. The 3rd Panther reversed at maximum speed, transmission screaming under stress loads it had never been designed to handle, black smoke already pouring from the engine compartment as superheated components began to fail. The tank made it approximately 40 meters before a 3rd round, fired from a completely different angle than the first 2, struck the thinner side armor and ignited the fuel tanks. 75 seconds had elapsed from first contact to the destruction of all 3 vehicles. 3 Panthers worth more than the annual budget of a small German municipality, crewed by experienced veterans who represented years of training investment, had been eliminated by an enemy force they never visually acquired. This outcome violated every assumption embedded in German armored doctrine. The entire tactical framework of Panzer operations in late 1944 rested on the premise of standoff engagement. German tanks were designed to kill enemy armor at ranges where return fire was ineffective or impossible. The Panther could destroy a Sherman at 2,000 meters. The Sherman's standard 75mm gun struggled to penetrate a Panther's frontal armor even at point-blank range. This ballistic superiority was the foundation upon which all German tactical planning rested. It justified the enormous resource investment in heavy tanks. It validated the doctrinal emphasis on offensive operations despite growing fuel shortages. It allowed German commanders to believe that individual technical superiority could offset numerical disadvantage. The mathematics seemed clear, and the battlefield results from Normandy to the Vosges had consistently confirmed them. Except the Americans at Stoumont were not firing 75mm guns designed for infantry support. They were firing something that represented an entirely different approach to the problem of defeating armored vehicles, something that German intelligence had identified but fundamentally misunderstood in terms of battlefield implications. The weapon system that eliminated 3 Panthers in 75 seconds was the American M36 tank destroyer, mounting a 90mm gun adapted from anti-aircraft artillery. This was not simply a bigger gun installed on a tracked chassis. It represented a complete philosophical divergence from German thinking about armored warfare. Where the Panther had been conceived as a main battle tank capable of engaging any threat while surviving concentrated fire, the M36 had been designed as a specialized ambush predator. It sacrificed armor protection for mobility and tactical flexibility. Its open-top turret made it vulnerable to artillery and small arms fire. Its thin hull plating could be penetrated by heavy machine gun rounds under certain conditions. By every metric of tank versus tank dueling, it was inferior to the Panther. But tank versus tank duels were not how the Americans were fighting this war. The M36's 90mm M3 gun fired an armor-piercing round at a muzzle velocity of 2,800 feet per second, generating kinetic energy sufficient to defeat any German armor at tactically relevant ranges. The ballistic performance was exceptional, but the real innovation was strategic rather than technical. It was the industrial capacity to produce these weapons in numbers that fundamentally altered the battlefield equation. By December 1944, American factories were manufacturing armored fighting vehicles at a rate that seemed to defy economic logic. The Fisher Body division of General Motors, a company that had spent the 1930s perfecting assembly line techniques for Chevrolet sedans, was now producing tank destroyers with the same methodical efficiency it had once applied to civilian automobiles. The Buick plant in Flint, Michigan, had retooled its entire production infrastructure to manufacture 90mm gun barrels, achieving rejection rates below 2% through quality control processes that German armaments manufacturers could not replicate even under ideal conditions. The Ford Willow Run facility, originally constructed to mass-produce B-24 Liberator bombers at the unprecedented rate of 1 aircraft per hour, had been partially converted to manufacture fire control systems and transmission assemblies for the M36 program. This was not the industrial output of a nation straining under wartime scarcity. This was the productive capacity of an economy that had solved manufacturing as a pure engineering problem, then scaled that solution to dimensions that European industrial planners considered functionally impossible. The strategic audit reveals a staggering numerical reality. Between January and December 1944, American factories delivered approximately 29,000 armored fighting vehicles to the United States military. This figure includes tanks, tank destroyers, self-propelled artillery, and armored personnel carriers, but excludes the thousands of additional armored vehicles produced for Allied nations under Lend-Lease arrangements. To contextualize that production rate, Germany manufactured approximately 19,000 armored vehicles during the same 12-month period, and that figure represents the maximum output achieved despite total war mobilization, slave labor, and the complete subordination of civilian production to military needs. The Americans were outproducing the Germans by better than 3-2, while simultaneously maintaining automobile production for civilian use, manufacturing more aircraft than the rest of the world combined, building Liberty ships faster than submarines could sink them, and supplying food and raw materials to Allied nations across both Atlantic and Pacific theaters. The logistical lung of American industry was operating at a capacity that rendered German strategic planning effectively obsolete. But this reality had not yet penetrated the tactical consciousness of panzer crews advancing through the Ardennes. The delayed realization came in fragments, in moments of cognitive dissonance that accumulated until they could no longer be rationalized away. The surviving crew members from the Stoumont ambush, those who managed to escape their burning vehicles before ammunition detonations turned steel boxes into crematoriums, reported back to their battalion headquarters with accounts that contradicted established tactical doctrine. They described being engaged at ranges where American guns should not have been effective. They reported multiple firing positions coordinated with a level of tactical sophistication that American units were not supposed to possess. They insisted that the penetrations they had witnessed were not possible given the armor thickness and slope angles of the Panther's glacis plate. Their after-action reports were met with skepticism bordering on disbelief. Officers suggested they had been hit by concealed anti-tank guns rather than mobile tank destroyers, because the alternative implied a fundamental miscalculation in German intelligence assessments. But the reports kept coming in from other sectors of the Ardennes offensive. Panthers destroyed by flanking fire from vehicles that repositioned faster than German doctrine said American armor could move. King Tigers immobilized by track hits from guns that were supposed to lack the precision for such surgical strikes. Jagd Panthers knocked out by converging fire from multiple directions, suggesting American crews were operating with tactical coordination that required radio discipline and fire control training the Germans believed the Americans lacked. The psychological impact of these engagements rippled through German armored units with corrosive effect. Panzer crews had spent years developing a tactical identity built on technological superiority. They were the steel edge of the Wehrmacht, the elite formation that could achieve breakthrough where infantry could not. That identity rested on the material reality of superior equipment, and when that reality began to erode, so did the psychological foundation of German armored doctrine. Crews started reporting mechanical problems with greater frequency, not necessarily because the problems were occurring more often, but because the prospect of combat against an enemy who could kill you before you could effectively return fire made every mechanical hiccup feel like a potential death sentence. Tank commanders became more cautious, less willing to expose their vehicles in aggressive forward movements, more prone to wait for infantry support before advancing. This was tactically sound in terms of individual crew survival, but strategically catastrophic for an offensive that depended on momentum and speed. The Ardennes operation had been conceived as a lightning thrust to the Meuse, a rapid exploitation of American weakness before winter weather grounded Allied air superiority. Every hour lost to tactical caution was an hour for American reserves to move into position, for supply lines to stabilize, for the numerical weight of Allied resources to assert itself. The technical specifications of the M36 reveal why it succeeded where German intelligence had predicted it would fail. The 90mm gun was a scaled-up version of the M1 anti-aircraft gun, a weapon system that had been designed to engage fast-moving aerial targets at high altitude. The ballistic requirements for that mission demanded extremely high muzzle velocity, flat trajectory, and consistent accuracy across varying atmospheric conditions. When adapted for anti-tank use, those same characteristics translated into armor penetration capability that exceeded anything the Germans had anticipated from American gun design. The M82 armor-piercing projectile weighed 24 pounds and struck targets with approximately 3,700 foot-pounds of kinetic energy at 1,000 meters, sufficient to penetrate 133 millimeters of rolled homogeneous armor at 0 degrees obliquity. Against sloped armor, the performance degraded somewhat, but the M36 crews at Stewmont had not engaged from dead-on frontal aspects. They had used terrain and tactical positioning to acquire flank and oblique shots where the Panther's armor advantage was minimized. This was the critical insight that German tactical doctrine had failed to integrate. The Americans were not trying to win tank versus tank duels through superior frontal armor and gun performance. They were using mobility and numerical superiority to create engagement geometries where those factors became irrelevant. The industrial mathematics underlying American tactical flexibility represented perhaps the most significant strategic miscalculation in the German war effort. Every M36 tank destroyer required approximately 11,000 man-hours to manufacture, using steel, rubber, and specialized components that flowed through supply chains spanning the entire continental United States. The Continental R975 radial engine came from the Continental Motors plant in Muskegon, Michigan. The transmission was manufactured by the Hydromatic division in Detroit. The gun barrel was produced at the Buick plant in Flint. The fire control systems came from multiple subcontractors scattered across the industrial Midwest. Final assembly occurred at the American Locomotive Company in Schenectady, New York, or at the Pressed Steel Car Company in Pittsburgh. This distributed manufacturing network meant that no single bottleneck could halt production. A bombing raid that destroyed the Buick plant would not stop M36 production because gun barrels could be sourced from alternative facilities that were already producing similar components for naval guns and field artillery. The redundancy was not accidental. It was the deliberate result of industrial planning that prioritized resilience and scalability over efficiency and specialization. German armored vehicle production operated under completely different constraints that became progressively more crippling as the war continued. The Panther tank required approximately 55,000 man-hours to manufacture, 5 times the labor investment of an M36, and relied on supply chains that were increasingly vulnerable to strategic bombing and raw material shortages. The Maybach engine plant in Friedrichshafen was a single point of failure for the entire Panther program. If Allied bombers damaged that facility, and they did repeatedly throughout 1944, production of new Panthers ground to a halt, regardless of how many partially completed hulls sat waiting in assembly facilities. The specialized steel required for the Panther's armor plating came from foundries in the Ruhr that were operating under constant air attack and chronic shortages of coking coal. The optical rangefinders for the gun sights were manufactured by Zeiss in Jena, a facility that could not be easily replicated or replaced. Every component in the Panther represented a potential choke point, and by late 1944, those choke points were being systematically targeted by Allied air forces that could operate with near impunity over German industrial centers. The result was a production system that consumed enormous resources to generate relatively modest output, and that output was becoming increasingly difficult to sustain as the logistical infrastructure of the Reich collapsed under sustained interdiction. The kinetic reality of the Ardennes offensive collided with this industrial mathematics in ways that German strategic planning had failed to anticipate. For every Panther destroyed at Stewmont or in the dozens of similar engagements across the offensive's entire front, the replacement timeline stretched further into an increasingly uncertain future. A Panther lost in combat in December 1944 might be replaced by March 1945 if production held steady and rail transport remained functional and fuel allocations allowed the new vehicle to reach the front. An M36 destroyed in the same engagement would be replaced within 3 weeks through a logistics pipeline that moved new vehicles from American factories to Belgian battlefields with assembly line predictability. The Americans could afford to trade losses. They could accept tactical setbacks that destroyed entire platoons of tank destroyers because the industrial base supporting those losses could regenerate combat power faster than the Germans could attrit it. This was not a comfortable calculation for the American crews who died in burning M36s, but it was a strategic reality that shaped battlefield outcomes regardless of individual sacrifice. The German crews at Stoumont and across the Ardennes front were experiencing the delayed realization that their tactical training had prepared them to fight a war that no longer existed. They had been trained to win through superior individual performance, better equipment, and more sophisticated tactical doctrine. Those advantages still existed in late 1944, but they existed within a strategic context that rendered them increasingly meaningless. An American tank destroyer crew with 3 months of training could kill a Panther crewed by Eastern Front veterans if they caught it from the flank at 400 meters. The American crew did not need to be better. They needed to be adequately trained and adequately positioned and backed by an industrial system that could replace their vehicle if they failed. The Germans needed to be perfect every single time, because every loss was effectively permanent in ways that losses had not been permanent when the Wehrmacht was advancing and German industry was operating at full capacity with access to occupied European resources.
The legacy of Stoumont and the broader Ardennes failure reaches beyond the immediate tactical lessons about tank destroyers and armor penetration. It represents the moment when the illusion of German tactical invincibility finally shattered against the mathematics of American industrial capacity. German soldiers had spent years believing that superior training and equipment could offset numerical disadvantage. They had won battles from Poland to France to the outskirts of Moscow through tactical excellence and operational audacity. But by December 1944, they were fighting an enemy that had solved warfare as a production problem. The Americans were not trying to field better individual tanks. They were trying to field enough adequate tanks to be present at every point of contact simultaneously. And behind those tanks stood factories that could replace losses faster than combat could generate them. This was industrial warfare stripped of romanticism, reduced to pure accounting. The nation that could build more, transport more, and sustain more would prevail regardless of tactical excellence at the company or battalion level.